Okay, so carrying on from the previous video, we have example 2. 5 cos x plus 12 sin x. And we wish to be able to rewrite that in the form r cos x minus alpha. That's what we're aiming to do. So we've seen already, we know the relationship between r and a and b, so r will simply be root of minus 5 squared plus 12 squared, which is 13. Cosine of alpha would be minus 5 over 12, and sine of alpha would be 12 over 13. This will lead to tan of alpha being 12 over minus 5. If we simply take the inverse tan of 12 over minus 5 from the calculators, we find this solution here of minus 1.176, correct to 3 decimal places. So let's have a think about that. Down here we see a quick sketch, and we see what quadrant this minus 1.176 radians would take us to. It'd be in this fourth quadrant, or the bottom right quadrant. And essentially we need to say, is that where we need to be? Let's have a quick look. We have cosine alpha to be negative. We have tan of alpha to be negative. In fact, it's only the sine that's positive. So if we look at this cast diagram here, we can see sine positive only is in this second quadrant here. So we need to really essentially move this angle all the way through 180 degrees, or pi radians. So we have to add pi to get to our solution. So if we have minus 1.176 and we add pi on our calculators, we would get 1.966. So alpha is 1.966. So our solution, another way of writing this, minus 5 cos x plus 12 sin x, would be 13 cos x minus 1.966. Okay, let's do another example. Example 3. 3 cos x minus sin x. Could we rewrite that in terms of r cos x minus alpha? Well, slight change from the previous example. Now the negative is in front of the sine term. So in terms of working out r, ever so straightforward. We have 3 squared plus minus 1 squared, square rooted, so we get root 10. Cosine of alpha is 3 over root 10, leading to sine of alpha to be minus 1 over root 10. Tan of alpha is just b over a. So what we find is, if we do the inverse tan of minus 1 over 3, we would get, correct to 3 dp, minus 0.322. Quick sketch of that would tell us it's in this bottom right, or this fourth quadrant. That's where the minus 0.3 would be. Is that what we're expecting? Well, let's just remind ourselves. We had a negative sine, we had a negative tan, we only had cosine being positive. So cosine was the only positive term. If we remind ourselves about the cast diagram, we see the cosine being the only positive term is here in the fourth quadrant, or the bottom right quadrant. And that's exactly what we have here. So all is well, there's nothing to do, nothing to change. So we can now say our solution is r is root 10 and alpha is minus 0.322. So if we put that in, we get root 10 for r, and we get cosine of x minus, which makes it a plus, 0.322. One more example perhaps when we have two negatives. Minus 2 cos x minus 3 sin x. Can we rewrite that in this form? So once again, r would be minus 2 squared plus minus 3 squared, square rooted, which will give us root 13. Cosine of alpha is minus 2 over root 13, and sine is minus 3 over root 13. If we therefore take tan of alpha to be b over a, we can see that b over a is just going to be what? It's going to be minus 3 over minus 2, which of course is just 3 over 2. So we have 3 over 2. If we do the inverse tan of that, what will we get? So we put that into our calculator, we get a solution, we see if it matches. Does it match? How does it fit in? and then we simply move it to the appropriate place. So it's positive, so it's up here in this quadrant. What do we know? What do we see? Well, we have here that cosine is negative, sine is negative. It's just tan that's positive. So let's look at cast again. And we see that tan is positive is in this bottom left or the third quadrant. So we have to get to there, if you will. So we're in the first quadrant and we have to get to the third quadrant. So we could come this way and add pi to our solution, but of course that would give us a value greater than pi, or we could come this way and subtract pi. Both would be correct, but typically we tend to want to write our alpha as somewhere between minus pi and plus pi. So if we take our value, which happens to be from the calculator 0.983, and subtract pi, we get minus 2.159. So our final solution would be root 13, that's r, cosine of x minus 2.159, which of course the minus makes a plus, and we have our final solution. Okay, thanks for watching.